Welcome to this webinar on how to accelerate maintenance, repair and overhaul with the theory of constraints. Subtitle, When Every Hour Matters. The table of contents is quite simple, a brief introduction, and then we're going to look at what is specific about MRO as a business, and then look at what the rules are of applying critical chain to MRO, and then examples, 11 examples, and then a conclusion. But we're going to concentrate on MRO. MRO has been used right from the beginning when critical chain appeared in 1997. One of the two first users was the US Marines in the US Air Force, and simultaneously Delta Airlines. They were two of the very first users, and Delta Tech Ops, as it's called today. And all that rolled out and is being used more and more intensely throughout the world. I'll describe why I believe it's a big part of critical chain is in maintenance. Okay, ourselves, well, it so happens that Marris Consulting's first assignment, we were born in the world of MRO, not aircraft MRO, but in railway MROs. For our first client and for our main client for the first 3-5 years of Marris Consulting, 19 years ago, was the French Railways, la SNCF. Which is a very large organization, right, with just in maintenance 25,000 people, right? There are 200,000 people in French Railways, of which 25,000 people spread out over 50 factories do maintenance. And that's where we were born, with chronologically freight locomotives, and then on to many other things, urban transports, RER, metros, and the high-speed train. So we did a lot of that, and then little by little we just did more and more of it. As you can see, we've done a lot in aeronautics, and some in mining equipment, mining trucks and all that sort of stuff. Okay, so it's the sum of this expertise over the past 19 years we're going to talk about, and it's in aircraft. It's both civil, such as people such as Air France, right, and more recently military as well. One of our main clients today in MRO is the French Air and Space Force, and we're helping them throughout France in all their air bases to apply this to the French force. I'm not going to have time in this short presentation to talk in detail about how critical chain works, right? How you build a plan, what is the critical chain itself, what's a fever chart, and so forth. And so for those that don't know much about critical chain, please, you can catch up easily by looking at the videos. The short version is a 5-minute critical chain summary, and the longer ones, that block there of 4, is 20 minutes each, which go through what the problem is, how to plan, how to execute, and how to improve. So it's all there for free on our YouTube channel. And we've also got a website dedicated to critical chain, which you can have a look at, which has lots of other stuff. Recommended possible software usage and all sorts of stuff, and a full dedicated website. So off we go. MRO, in what is specific about MRO, right? I think one of the reasons why MRO was one of the first users of critical chain and continues to grow month by month in significant proportions is, compared to other domains in which you can apply project management, it's a lot easier unambiguously to calculate how much you're going to gain by finishing your project one day earlier, okay? Because you know exactly how much you're making with your aircraft, right? If it's a civil aircraft, you know that if it's not available to be filled with paying customers, then you're losing so much money, right? It's about between $50,000 to $300,000 a day, right? Depending on the size of it, from a smaller one to an A380, whatever, that sort of stuff. Anyway, it's a lot of money, and so it makes sense to work hard at gaining a day, cutting off, shaving a week off, and so forth, right? And the same is true, of course, more recently in anything to do with military MRO, because the availability of the fleet is obviously key to the business. Okay. And the same is true in the railway industry, especially as it depends on your geography, but if I take Western Europe at the moment, as more and more people are taking the train, it takes a few years to build new trains and have more trains. So at the moment, in nearly all countries in Europe, there are not enough trains, so you want to make sure that when they go in for overhaul, they come out as quickly as possible, right? Because you're losing capacity when you do that. In the mining industry, machines and trucks and stuff, it often happens that you have for instance, your trucks or other part of your mobile equipment that is the bottleneck of your mine, and therefore maintaining your truck will be the improving the capacity of your bottleneck. Anyway, the list is very long, so it's easy to know what you're going to gain if you shave a day or a week off. Okay, and it's one of the reasons why there's so much going on in this field, right? Now, what are the problems? What are the specific things? I'll go through this fairly quickly because nearly all of you are people from the MRO business, so you know already what your business is like. One of the key things is, of course, that there's a lot of uncertainty. An aircraft coming in for a C check will have a certain number of parts, things what you just check and eventually replace or not. But you're then going to have findings, things that you would not expected because this aircraft has been in a saline environment, or there's been some problem in part of the aircraft. Okay, so you're going to discover findings that you're going to have to do that were not expected. Okay, and we'll describe what the solution is. There's also a lot of problem of visibility with the execution progress. Too often people don't know 48 hours before if the plane is actually going to be coming out as promised in 2 days' time, right? Because they're not sure, because it's not clear what's going on with all the different job cards that have to be finished and all this sort of stuff. Another typical problem we find in nearly every MRO business is there's not enough full kitting. That's to say, the people doing the work on the objects spend too much time looking for the tooling, looking for the documentation, looking for the consumables and stuff, right? Delayed findings we'll talk about. You should really try and to get rid of the uncertainty. You need to identify all the work that needs to be done, including the work that was not scheduled, right? And to do that, you need to work in a different way to make sure that you don't have a last-minute surprise. That's what you want to avoid, because then, of course, you're going to have trouble finishing on time. And then there are constraints. Depends a bit on the business, but typically, let's take an aircraft. There's a lot of stuff to be done in the cockpit, and the cockpit is only such a given size, and you can't have 20 people working simultaneously in the cockpit, right? Or you have safety concerns, right? You can't do this because you're going to risk electrocution of somebody else if they're working on another part of the object, all this sort of stuff, right? So there are all these constraints to be taken into account. And one of the things we find is that nearly every time there is too much work in progress. There are too many aircraft, there are too many trains or locomotives being worked on simultaneously, so people are spreading themselves thin and turning things into bad multitasking with all that entails. Anyway, this is just describing the environment that we usually discover. And because of all that, we often find that people have got the mistaken assumption about what the problem is. In particular, people tend to claim that there's a problem of capacity. I don't have enough mechanics, I don't have enough space, I don't have enough of this or that, when in fact we find that very often there's an excess capacity. You can produce quite a lot more. You'll see the numbers in the examples. You can produce 30, 40, 60% more with the same resources, the same people, the same hangars and stuff. Okay. Now, the existing schedules or plans are usually more or less impossible to understand, right? That's a real-world example there of each of those being an aircraft in a large organisation. Well, that doesn't help much, does it? It's going to be where it is right now, but of course there's probably somebody full-time moving those things around as the aircraft, since that's an aircraft example, finish late, and so it's very hard to know exactly what's going on, right? Why is it so hard to identify the progress on a portfolio and on a given aircraft? Well, there are thousands of work cards, right? When you do check C on an A350 or something like that, you're going to have several thousand work cards. These work cards each identify a specific item of work that has to be done, and to ensure that all the work was properly completed and checked and stuff. You have to complete these work cards and say, yes, I've done that, I've checked that part and put it back and whatever. Okay, so several thousand, and that's too much to understand exactly what's going on, especially because the dependencies that there might be within those work cards are not clear, right? And furthermore, in quite a lot of the cases, more than half of what we found, the work cards are not systematically declared finished at the end when they've just finished the work, or at least at the end of the shift, right? So you've got some organizations, I know it's not good, and it's not the case of everybody, where they have to run around when they've finished the work, the plane is ready, or they think it's ready, but they can't find that or that work card which has got lost or hasn't been put into the system properly, all these sorts of things. Okay. And also it's difficult because of the problems of coactivity, right? I mentioned in the cockpit and stuff. You'll send somebody off to go and do this on that aircraft, and they'll come back half an hour later and say, I can't do that because there's already somebody working on something else there. Okay. And then you do have, this is the theory of constraints, some limited resources of some sort, right? But usually it's just a limited population. It's not true to say that there are constraints in all your different labour specialities and stuff like that, and so it will depend on your environment, whether it's the people doing the non-destructive testing, it might be your paint shop, it might be your metal sheet workers. Somewhere in there, somebody's got the short straw and is the constraint of the system, right? This is all about theory of constraints. So obviously we know, don't we, that it's not true to say that everybody is overloaded. Everybody works at the pace of the bottleneck, and the bottleneck is one of the resources somewhere in the system. So this is just to say, once again, to better use the people doing the work, right? You have to make sure that they have a full kit, they have the parts to work on, they know what they have, the work card and they can declare it, they have the tooling, they have the consumables, and of course they have the skills required to do the work. This one, I guess, I'm emphasizing it for a whole slide because it's kind of surprising to what extent we have to repeat this time after time after time. The findings have to be done as quickly as possible, right? You really need to focus the teams to pull as much as possible, pull the locomotive or the train or the plane apart with an idea that you need to find the findings, right, as quickly as possible. And if you know that kind of train has a problem in its suspension and stuff, then specifically disassemble the part of the train where you know it's possible that there's a corrosion problem because of the previous experience and all that sort of stuff, right? You really need to do that. And certainly you want to avoid having findings that are discovered very late in the process. I'll give you a horrible example. It's a real world example from a fairly reputable large MRO organization in civil aircraft. They had subcontracted the work of opening up the hatches and stuff to some people outside of their organization. Okay, and that was then meant, those body fairings and stuff were meant to be inspected before going back onto the aircraft, but they weren't initially, right, as they should have been, so that when it came, the aircraft was ready to go and they started putting the body fairings back, they said, oh damn, this body fairing is damaged, we're going to have to repair it, it has to be sent to the metal workshop, and off it went. But that was sort of 3-4 weeks too late, and it was the whole plane was going to wait because that body fairing, they didn't have a spare, had to be repaired urgently, right? Of course, you should avoid that sort of thing, but if I'm taking the time to say that, watch out. We've found that often about 30% in a large organization, about 30% of the aircraft's delayed ends are due to the fact that the findings were not detected early enough. They could have been easily detected earlier, body fairings in particular. Too many aircraft. This, for those who know Marris Consulting, not just within MRO, know that we say this about anything, whether you're making Swiss watches, dog food, or satellites or whatever. There's always too much work in progress. If there's too much work in progress, you have long lead times. That's Little's law, right? The more objects you have in your system, the longer you have to queue, you have to wait, okay? And so you need to reduce the number of things you're working on at the same time, right? Whether it's aircraft, ships, trains or whatever, you need to try and focus everybody on a more limited number of objects and work on those much more quickly. You can, because you have twice as many people working on half the number of items will go twice as fast. Common sense, isn't it? Well, then, how come whenever we go into these systems we find there's an excessive quantity of work in progress? Okay, that was a quick overview of what's specific about MRO. Let's have a look at what the critical chain solution is. I hate using that word, but anyway, there it is. For us, you must understand that there are 3 different levels. It's a control pyramid that needs to be installed, of which critical chain is just the middle level. Okay, the top level is hangar or system management for the whole portfolio, and it determines the relative priorities of the different aircraft or the different trains in your factory, okay, using the portfolio fever chart that you can see there, okay. But it's all about choosing in particular when I start on a new object, a new train, a new plane, because often the later the better, right? I remind you, I just said you need to keep the number of different items you're working on at the same time down to a minimum, and therefore one of the key decisions is to launch your new one not too early and not too late. Okay, that's what hangar management is all about, and often it's later, right, that you want to do it. Scheduling the critical chain way, this is the heart of the critical chain approach, right? And I'll give you a few examples later on. Okay, and it involves obviously risk management because of the uncertainties in this kind of work, and the relay race principle, which I'll describe, which is quite simply that the critical chain, since it's unique throughout a given object, you need to make sure that that sequence of tasks, which is determining the overall duration, is done as efficiently as possible without wasting time, like a relay race in an Olympic race. Okay, and finally the bottom level is the management of operations and executions with the daily workflow, handing out work, monitoring what's going on, and making sure that everybody has a full kit. Okay, you'll see some surprising results in terms of increases in in durations, but in productivity, right? Doing 30%, 60%, even sometimes 100% more aircraft with the same number of people. And that is because too often, if you go into an environment of MRO and you look around, the people doing the work are not actually working. They're looking for something. They're looking for the tooling. They're looking for advice. They're looking for permission. They're looking for something or other, and not doing value-added work, right? And what we need to do is make sure that the full kit is there so that they can work more efficiently. Dynamic scheduling, right? Well, let's go into the level of how you schedule one aircraft. Okay, forgive me, this is going to go fast, but you're going to have a copy of all the slides at the end if you want to come back to this one, because this is a real world example of an aircraft, okay, with a before and after. And as you can see, what was happening before is that they had scheduled multitasking. They had expected people to work on all the different parts of the aircraft at the same time, and therefore it was going to take quite a long time since everybody was spread thin on the engines, the landing gear, the fuselage, the wings, or whatever. Okay, so you change that by making sure that you have more teams with more people, right? There used to be only one mechanic on that particular job. A landing gear, for instance, and you say, okay, let's put 2 people. It'll go twice as fast. Okay. Now that doesn't mean we put 100, right? Because, for instance, on a landing gear of a small business jet or something, 3 people you're probably going to get in each other's way, right? So 2 is the answer. 1 is not. It could go to 2, but 3 would be too much. Anyway, so you have to work out what the right quantity of mechanics and people is to do the various tasks without them getting in each other's way, but using as many hands as possible, right? And you have to, of course, keep in mind that the risky zones, which often people in the business know, right? Cockpits in aircraft and in trains, in fact. And then we do the critical chain part. Again, look at the videos if this doesn't make sense as I summarize it. You're going to have ambitious estimates of the task durations, right? You ask somebody, how long is it going to take you to do this task? And you're going to ask them for a task duration that is ambitious, which has only a 50% probability of being honored, right? It is not a commitment, okay? And it assumes that they're working in perfect working conditions, that they have the tools, they have the work order, they have whatever it is, okay? So they give you these reduced focused durations, and simultaneously for the same task you should be asking them, and if you have a problem, if that's rusty or if you have trouble with that, whatever, how long could it take? And so for each individual task, normally they should be giving you 2 different durations: the ambitious focused duration and the pessimistic longer duration. Okay. And as I mentioned, you should make sure that you plan all the inspections as early as possible in the system, and you anticipate all the additional work. You add findings buffers. That's to say, you say, I think there's likely to be a problem of corrosion on the wings, and if that happens, it's going to take me 200 hours of metal sheet workers to fix it. Okay, I plan that in the schedule. Okay, so that the workload and the structure and the planning is there, right? Now, what do you plan, what you don't plan? To keep it very simple at this stage, maybe people want to talk about it in the Q&As. We just have a very simple rule: is if it's more than 50% probable, you plan for it. Okay, and this is the same for the spare parts, right? If it's something that is not expected in the documentation, I do not normally need to change this at this 98-month check. Okay, in practice I've looked, and in 80% of the cases of that aircraft I do have to change that part, so I'm not going to I'm going to anticipate that and make sure that I have those spare parts. Okay, so you've got there the example of before and after with the buffer, right? The buffer is key, of course, to critical chain, because having scheduled things with all these ambitious durations, right, that's never going to happen properly, right? There are going to be problems, people are going to take more time, and therefore you have a global buffer shared by everybody that enables you to absorb the problems that people are going to have individually as they go through the different tasks, right? So there's a global buffer for the project, which will absorb all the problems that people might have. Okay, have a look at all the videos about critical chain approach to understand this logic. That is the underlying conceptual key to how we do that. Okay, this leads us to the critical chain. The critical chain there in red is the sequence of tasks. So close cousin, by the way, to critical path, for those who know what critical path approach is. So it's the sequence of tasks where there is no slack, but it takes into account the predecessors. Let's say what sequence of work, right? I have to dismantle something and check it before and then put it back again. And it also takes into account the resources, right? And so here the fact that we only have one Peter as a mechanic means he will do one thing then the other and so forth, right? What is specific and special about the critical chain compared to critical path is that, as you can see here, it's in one particular sequence, and we keep it that way throughout. The blue stuff, which is non-critical, is kept non-critical by having buffers also to ensure that they don't get in the way of the critical work. And then you can improve the overall work by focusing just on the sequence of tasks that are critical, right? And that's a simplified example here. Obviously, since there are thousands of tasks, I said, in the system, you're going to have something that's massively blue, right? When nearly everything's blue, you're going to be focusing on that one sequence. There's just only one place at any one time in one aircraft to ensure the success of the project. Okay, and there would be a mascot to ensure that relay race principle. One of the keys of MRO is to make sure that you choose the right granularity of your model. Okay, and typically, if I take an example, which you'll see in a few minutes, about a business check C, 96-month check. Okay, they had 1,200 work cards that they had to do, and they grouped those, made packages of work cards, and then they managed 170 work or card packages, and that was the vocabulary and the unit that they worked with among themselves, and that was the right granularity so that people could understand what was going on. Okay, and those are the ones that are scheduled in the system. Those are the words and what people are using. Okay, and the level below that can be managed in different ways. It can be just checklists within a package, for example. Okay, and if this surprises people, that's why I put work packages 50, 100, or 200. Often people hesitate to go down to 50 or only 100 work packages. Okay, and so they have more than that. They have 200, they have 300 initially. Okay, that's fine. It's just little by little, after a couple of years, once you've got more confidence in your system, you'll realize that you were micromanaging things, and probably you could go down to just 100 work packages, even on large aircraft. Check C. Certainly that's what we find in all our mature users. They understand that, you know, once it's properly set up, you don't have to get into great detail to ensure that the work is finished not only on time but early. Another key for us of managing these operations is to have what we call a control tower. Often in the same open space, we get people that are representing production, representing supply chain, representing quality, representing sometimes the supplier of the aircraft, if there has to be interaction with I don't know, Airbus or Dassault or whatever. Have everybody in the same room so that they can quickly take the decisions and move the thing forward at the speed of light. Okay. On the execution level, this is an example of execution. You've got on that board there, you've got packages of work cards, right? Those blue paper things. In this example, you've got the fever chart, which shows the progress of the planes in the hangar, and a macro design of the work breakdown structure so that everybody understands what's going on. Everything's kept nice and visible. Okay, obviously year by year things are getting more and more digital. That's fine, we do a lot of that, but you need to have some kind of digital representation that keeps things visible, right? Make sure that there's, in some way, you know exactly what's going on visually speaking. That can be a board here, as we have a physical one, or it can be a large screen with the equivalent information. But watch out, we're seeing this a bit too often. Going paperless is fine, but make sure that that doesn't blind you, doesn't remove your visibility to what's going on. Okay, and obviously, but this is because we love critical chain and the portfolio fever chart. One of the most simple and lovely visual management techniques is the portfolio fever chart, which you can see an example of there, and we'll see a few more as we go through. Okay, it gives you just in the size of a postcard, it tells you what's going on, right? It's crazy. I hope you will wake up at 3 o'clock tomorrow morning saying, I want a portfolio fever chart for my MRO. The management of capacity, this is an example where they had 15 aircraft doing MRO, completely overloaded. Was linked to the very increased demand for military jets in Europe. So there was everybody wanted to upgrade, maintain all the fighters, and it just led to completely excessive workload. And a lot of frustrations and stuff. The answer is, as you can see here, quite simple. Just stand back, please, and make sure that with the appropriate model, you're capable of doing some master scheduling, whatever you want to call it, and work out how many planes you're going to do, how many planes you should have in work in progress, and so forth. And watch out, again, this is just theory of constraints. It's not everybody, it's not a complicated calculation. You just have to work out what the bottleneck is in your system. As you can see here, in this particular case, and we find that quite often, if the aircraft are old, it's quite often the metal sheet mechanics, because you have not properly budgeted the number of work hours of metal sheet mechanics, because you haven't properly modeled how much corrosion, how much repairs on the metal sheet is going to be required. That's what was happening there, right? And yet you had plenty of avionics people in this particular example. Right, so all you have to do is make sure that you schedule according to the capacity of the bottleneck. The bottleneck in this example was metal sheet mechanics. Reduce work in progress, reduce work in progress, reduce work in progress, reduce work in progress, right? Stop, starting, start, finishing, all this stuff. And what happens if you don't? Well, you get what we have on the left-hand side. Lots of trains, lots of wagons, lots of ships in the yard, lots of aircraft in the hangars, and everybody just screams at each other all the time, and lots of discussions about which is the priority between that one and that one and that one, right? You just filled up your system until it bursting at the seams. Don't do that. It's just simple rules of flow, right? Make sure that you keep the things flowing, and therefore the most important decision, I said it earlier, is when do I launch a new unit into the system, and probably the later the better, right? If I start later, I will probably finish sooner. I repeat, if you start later, you'll probably finish sooner, because if you have that hygiene, the queues are fewer, and if you're going much faster, everything flows through your system much faster. The fever chart I've already talked about. This is what I want you to wake up with and say, I want one in the middle of the night. This is the fever chart of a portfolio with several aircraft. Okay, on the horizontal axis is the work to be done, going from 0 to 100% of your job, and on the vertical axis is the consumption of the buffers of each of your aircraft. Okay, and what you promised to your external customer was to deliver your things at the top right hand corner. That's to say, with all the buffer consumed. It's what it's there for, right? It's perfectly normal. Okay, indeed, you aim to try and finish all your aircraft a little bit early. Okay, a little earlier than what you promised, so that you don't get into some mad and sometimes dangerous rush at the end of your work, right? It's just like what you do when you're catching an airplane, right? What you do to not miss airplanes, you aim to be, you finish the project of getting to the airplane a little bit early, and you waste the time at the boarding gate so that you don't miss your plane. No, apply the same rule in your business, right? Whatever it is, that's the way to do it. So normally when it's all set up properly, you should have about 80% of your aircraft in the green. That's to say, they're finishing early without any big deal, any big managerial attention problems or whatever. And you do some exception reporting on the aircraft that are in the red. Often you see these very early on, because they've had, during the inspection, you find you've got many more findings. Oh dear, there's a nasty bit of corrosion at the wing level of this aircraft. It's going to be difficult, and you find that out. You know, the aircraft's only just arrived 3 days ago, and you already know that aircraft's going to need a lot of attention. This is nearly the opposite of what we see in a lot of MRO companies, where everybody's management attention is on the aircraft that's just about to leave or should have left yesterday and all that sort of stuff. Nobody's looking at the new one that's just come in, that is going to be tomorrow's fire, right? We recommend to increase the dosage quite often, because there's pressure to finish your aircraft quickly. There's some work that you decide not to do this time, you do it next time and stuff. So the you're giving back your aircraft or your train or whatever to operations with only a limited amount of autonomy before it has to come back, because you haven't done the full work, or you could have done even more. Sometimes also for regrettable cost accounting mistakes of judgment. Anyway, so make sure you try and aim for having an aircraft where you've given it as much potential as possible, because otherwise you get into a nasty spiral of things having to come back very often, and it just goes mad. A few examples. Now, there are 11 examples here. I can't. Each one I could have a webinar about, right? So I'll go through them fairly quickly. Fasten your seatbelt, the tablet in the upright position, all that stuff. And then with questions and answers, maybe we can come back to anyone, the ones you wish to have. I remind you, so there's some busy slides coming up. You have a copy of all the presentation available, and you'll have a recording of what I'm saying, so you can come back and go through this more slowly later. Okay. This one here is Embraer business jets in Paris. And some of the examples of photos come from that example, because it's a nice, I like it, example. Okay, we started on the check seas, or the 96-month checks, right? And they used to take well over 10 weeks before we started. And we aimed for and achieved 5 weeks right from the word go, right from the first pilot. It was down to 5 weeks, and in fact, it then went into continuous improvement mode. Sorry, it used to take 10-12 weeks. First one we did with the pilot was 5 weeks, and then they went into continuous improvement to get down to 3.5 weeks for this particular kind of check on Phenom, I believe it was. And they just applied everything that you've heard, right? And several of the numbers I've given you, going from 1,200 work cards down to 170 work packages. The one of the things that they discovered when they analysed the critical chain, the sequence, was that they had to change a bladder, or clean a bladder, sorry, a tank for the kerosene, and they had no specific tooling to do that, so it was very inefficient. It took 300 hours or something on the critical chain, and so they thought up some tooling which enabled them to clean it much faster. Since it was on the critical chain, I think they took it from 300 to 100 hours. That shaped up 200 hours off the turnaround time, right? Because they were working on the critical chain. Lots of lovely stuff. And there's a 1 hour video by Embraer available, so you can have the long story of that one. This one a bit more confidential because it's military, so we can't say much about what was going on. It's F-16, not just maintenance, but a significant overall modernization of a huge fleet of many, I can't give the number, F-16s. So this is at large scale. The whole thing was completely overloaded because, well, it was a nice spiral. That's to say that they started working on this modernization, and it was taking 3 years elsewhere in the world, and they applied critical chain, and they got down to 13 months to do the same thing, right? So it was taking 3 years in the rest of the world, 13 months here. As a result, their client said this is fantastic, and they started sending waves of F-16s to the site, and so there was a problem of making sure that they didn't have too much work in progress in the system, hence the calculations you saw in some places, right, to keep everything flowing. Okay, and a lot of stuff, and a great ongoing success story, in fact, because that was there's still a lot of things that they can improve as they do this. It's kind of different, this one, because it's true that it was getting fairly repetitive. The numbers are important, right? Just exactly the same operation, basically, on aircraft that had good historical knowledge of what you would find, what findings you would have, and so forth. So it's kind of special because of the volumes involved. This here, the US Air Force, is not a Marris Consulting project or client, right? I mention it because they're just huge, right? The number of aircraft is mind-boggling. And you can have all sorts of details of information by publicly available, well, some of it is publicly available. Look up Tesseract, you've got the name up there in the top right-hand corner, Tesseract, for example, on LinkedIn. They have regular, twice a year, they give an update of what they're doing, and as you can see, they're doing it all over the world, in all their air bases, in all kinds of aircraft and stuff. It's very, very impressive. Another large user of the theory of constraints in MRO, not just aircraft but also naval, is BAE Systems. And you've got an example here where they were at the beginning of the year in 2023, October 2023. That's where they were at the stage of rolling out. It all started back in Australia when they applied the critical chain to the Royal Australian Air Force Hawk jets, and that little by little came to the attention of top management, and it's now being used throughout, from submarines to tanks to aircraft and so forth, right? So that's another big recent story. This is just our historical Marris Consulting client, right? It's where we were born in the maintenance and overhaul of aircraft, of trains. Okay, we started with freight trains. That's got some examples of a freight train there, and we went on to all sorts of stuff. But the iconic high-speed train TGV, train à très grande vitesse, which we took the modernization times down from 67 days to 38 days, and then back down. They continued after we'd finished accompanying them down to a lot less than that, right? And with significant reduction in number of hours per renovation, and lots of good stuff, and that's obviously important because French geography is obviously in need of a lot more trains as people use the train more and more. This one here is in another one very quite similar to Embraer's in Le Bourget, but it's in Prague in the Czech Republic. ABS jets, reputed to be one of the fastest, certainly in Europe, maybe in the world, on the kind of aircraft they specialized in, and yet they started on at 7 weeks for a C check and went down to 4.5 weeks, right? So even if you're already very good, right, you can probably go a lot faster using critical chain. This was their example. They were already, I repeat, before implementing critical chain, considered the best in their market, and they managed to not quite double but go a lot faster, right? Have a look at the videos, the client testimonials and so forth, if you don't believe me. This here is an example of a fever chart of a single aircraft, okay, and it's a large civil aircraft, and just for those who are not familiar with what it looks like, right, when this is a real world example where you start down here, bottom left hand corner, everything goes fine at the beginning, and then as they're about 1/3 through, right, suddenly bing, something goes wrong, and they find that they have extra findings that were not expected, so they're not progressing anymore along the critical chain. In fact, they're burning up the buffer, right? It's going up vertically or even back a little because there's extra work to be done. And so they react, they find solutions, and off they go. In this particular case, they finish just on time. But I repeat, normally you aim to finish things a little early to avoid all the pressures and stress of the finish. Okay, and you have the slides. You'll be able to read all the examples of, in the real world what happens. We're talking about real world aircraft with problems of various forms. This here is one I can't give too much details of for military reasons. We doing a lot of this work, okay, and it's the same as civil aircraft, same solutions, okay, and the same kind of results, if not slightly better, since the productivity we're finding is improving. Even more than 30 to 40, even sometimes 50% increase in productivity. Let's say the number of checks that they can do in a year on a given military base. Okay, and the availability is going down. It probably in other circumstances it could have gone down further. The turnaround times. It's just that in this particular environment, there's still quite a bit of supply chain problems of availability of parts, and that's what stuff that's now become the constraining factor. Okay. We've talked a lot about objects such as aircraft, such as trains and ships and stuff, but the same can apply to equipment within an MRO. We've done dozens of projects where you're working on part of an MRO. Right, this one here is one of the it's the largest company in terms of the MRO of landing gear in Europe. Okay, it does a huge proportion of European landing gear maintenance. Okay, and it's a little different because of the volumes, right? You've got many more units coming out per month, but the basic rules are always the same 3-tier scheduling system, same 3-tier control pyramid, and the same increases in output, reductions in lead times, and so forth. Right. So what's true? It's a bit like Russian dolls. What's true about the object as a whole will also be true for individual parts, right? Whether it's the engine, the landing gear, or whatever. So that's it from the examples. Have a look at the websites, the videos and stuff, because there's other stuff there. I couldn't go through it all. There's the stuff we've done with mining. That's that little truck there is from a gold mine, and all kinds of aircraft, whether civil or military, and as I say, lots of stuff from the railways and helicopters. I don't know why I didn't even mention helicopters today. Helicopters exactly the same. Indeed, the proportion of maintenance for an hour flight is more significant. So the stakes are high in helicopter maintenance, aren't they? To conclude. Well, why not give it a try? It's a match made in heaven. Critical chain in MRO. I tried to explain why, and I haven't really explained how the the methodology works, but it really is a match made in heaven. You're getting reductions in downtimes of 20, 60, even sometimes more percent, right? So you should really be able to reduce by half most of the time. And not only that, you get an increase in productivity, which is in Western Europe, where based is getting more and more important, because as the number of aircraft flying goes up and up and up year by year, right? There's more and more maintenance to be done, and we're finding there is a real constraint now of availability of labour to do all this maintenance. Okay, of course, it's nice, isn't it, to finish on time. I don't know what your performances are, but all the people using this stuff usually end up with a basically 100% on-time delivery performance and visibility and stuff. So that's really cool. And then there's all the quality of life things, which really maybe that's not what you're worrying more about short-term financial or operational benefits, but it's a different world when you're doing things in this way, because of that visibility, because of getting people to work on the source of the problem early on rather than firefighting at the end, and planning for bad stuff to happen. I don't know if you've understood what I'm trying to summarize in terms of risk management, right? The best way of getting rid of the risk is to prepare for them, right? So if I have the appropriate spare parts and stuff, that's cool. Okay, so that's it.